Hello everyone. Welcome again. Welcome to the webinar on beauty of structures. Welcome to the wonderful afternoon. Let me introduce IASTRACI, the organization. Indian Association of Structural Engineers is a national apex body of structural engineers in India, established with the primary objective to cater for the overall professional needs of the structural engineers. The association provides opportunity for all its members to develop skills in structural engineering and also helps them to be at the forefront of structural engineering practice. Towards achievement of these goals, we do organize several webinars, professional courses, refresher courses for the young engineers related to the state-of-art technological topics, student orientation programs, seminars, technical lectures, technical discussions, so on and so forth. The organization works as a mouthpiece for the structural engineers in India. It is purely a professional learned society with the prime objective of supporting and protecting the profession of structural engineers. So I request the participants who are not yet a member of IASTRACI, please visit our website and become a member. Now coming to today's webinar, let me introduce our dynamic moderator, Professor Mahesh Tandon. I'm privileged to introduce Professor Mahesh Tandon. As such, he doesn't need any introduction neither in India nor else in any other world. Professor Mahesh Tandon is the past president of IASTRACI and one of the doyen in the structural engineering fraternity. He is one of my favorite structural engineer. He is not only an international expert in the field of structural engineering, he has accreditations of International Professional Engineering India. He has made significant contributions in the development of culture for innovation in structural engineering, both within and outside India. His organization by sharing his expertise and experience. So with this introduction, I'll hand over the platform to Professor Tandon. Professor Tandon?
Yes.
We'll take over from here.
Am I audible?
Yes.
Loud and clear, sir.
Loud and clear. Okay. Thank you so much, Professor Visalakshi. It's always a pleasure to hear your lilting voice in the beginning of the seminar. And I think this seminar, since it has something to do with beauty, it is so pleasant to hear somebody speak so fluently and effortlessly and in a lilting voice, anything that the person says, and that is Professor Visalakshi. So coming to today's program, friends, we have what the program that we have in front of you is that first I will make a few opening remarks and introduce the speaker of today, that is Professor Knut Stockhausen. Don't be shy of pronouncing the K because that is how it is pronounced in Norway, but that's where he comes from originally. So Knut Stockhausen, that is the name. I hope that I got it correct though.
Wonderful.
After this introduction of the speaker and a few words, I will hand over the floor to the speaker who will go through his presentation. Thereafter, I will speak the elite panelists that we have, consisting of three of our very important and well-known structural engineers of the country. And I consider Dr. Mike Schleich who's one of the panelists as a part of India, because his association with the country and projects in India goes way back to at least 40 years that I can think of. So he's one of the panelists, and then we have Mr. Hegde and Mr. Alok Bhaumik, our current president. I will, of course, read out a short CV of these gentlemen at the conclusion of the presentation by the speaker, and then we will open it to the open it for question and answer. And please don't forget that you can put your question and answer in the little box that you see at the bottom of the screen, and so they will be all taken up by the speaker or one of the panelists, as the case may be, and then we will finally call it a day. Okay, so talking about beauty of structures, this is one of my favorite subjects, and that is why I am very eagerly looking forward to this presentation. Let me just read out to you a few paragraphs that I had written, not a few, just a couple of them. The traditional concerns of safety, stability, durability, and economy, for the most part, have always been perceived as being in the domain of the structural engineer's responsibilities. However, great structural engineers have gone much beyond these concerns. Aesthetics has remained in the gray area where both structural engineers and architects have been involved in a project. But if you go back in time, structure as an art form has existed separate and independent of architecture for a long time. You have only to look at the Eiffel Tower, that is Gustave Eiffel, France, or the Brooklyn Bridge, Roebling of USA, or the skyscrapers of Fazlur Khan of USA, or the creations of structural designers like Thomas Telford in UK, Robert Maillart and Christian Men in Switzerland, Eugene Freycinet in France, Franz Dischinger, Fritz Leonhard, and Georg Schleich of Germany, Felix Candela of Mexico, and Nervi of Italy, to realize that these structural engineers created the most significant and enduring art forms of the last more than 1.5 centuries. The structural engineer's creativity and imagination substituted for any significant inputs that could have come from an architect. So with these few words of opening remarks, may I now ask the speaker of the day, Mr. Knut Stockhausen, to please take over and give us his presentation. Thank you.
Thank you very much, Professor Tandon, for the introduction.
I beg your pardon. I think I have to introduce you too. Just give me half a minute.
Go ahead.
Mr. Knut Stockhausen is a structural engineer and partner of Schleich Bergermann Partner, an internationally renowned structural engineering and consulting firm based in Stuttgart, Germany. Knut graduated from the University of Stuttgart in 1999 and joined SBP, as it is in short, the firm called Schleich Bergermann Partner, in 2000. As a project manager and team leader, he successfully supervised a great number of large-scale, long-span, high-rise, and multifunctional sports projects. In 2008, Mr. Knut joined the management of SBP and founded SBP Latin America in Sao Paulo, Brazil, expanding the international network of the company. In 2015, he was appointed partner. Today, Mr. Canute develops and manages diverse projects and supports design partners and clients all over the world. Maintaining a hands-on approach that goes beyond structural engineering, he likes to be involved throughout the whole project process, from the early project development phase to detailed design, site monitoring, delivery, and handover. Mr. Canute's work has earned him numerous awards, both in Germany and internationally, as most recently for the Wanda Metropolitano Stadium in Spain. He enjoys sharing knowledge and frequently lectures on the beauty of structural engineering. Now, may I hand over to the speaker, Mr. Canute Stockhausen.
Thank you so much for this kind introduction. Can you see just the presentation slide now?
Yes, sir. We can see.
Wonderful. And then there is a slight echo, so maybe if you switch off your microphones, then
yes.
you can listen maybe better. So
yes.
first of all,
if I can just interrupt, can everybody please mute themselves? And whenever there is after the presentation finishes, we will see whoever speaks can unmute and speak. But at the moment, please mute yourself, everybody.
Do you see the video as well here?
Your video can be seen.
I'm just trying to get rid of it like this. Okay. Sorry. Okay, thank you very much for the invitation to speak in India today, while I'm sitting in Stuttgart, which is actually related to this peculiar situation we're all in since 12 months now. But it doesn't limit the joy and pleasure that I feel to be exposed to to a country where I also spent quite a while in, as you will learn during this presentation. So as you mentioned, I'm a partner of Schleich Bergermann Partner, and I joined there 21 years ago, which is already a long time. And but I want to express my gratitude because I studied from 1995 to 1999, mainly under the let's say motivation and guidance of my dear mentor Jörg Schleich, who is the father of Professor Mike Schleich, who is present here in the panel today. And Jörg Schleich actually guided me to what I believe I am today as a structural engineer. And you may see this also during this presentation. So the lecture today is in principle an homage to the beauty of structures, and actually to those who knew this all the time. You mentioned so many names in the beginning of this lecture, and many more could be added, but so in principle, their heritage can be seen in all this work. And my presentation aims to show how I believe, how we believe this beauty can help to pursue one of the most important aspect and pressing challenge of modern mankind, and that is sustainability. Now, sustainability is a big word, but at the same time, it is a very empty word without somehow trying to fill it with life. I remember clearly the words of Jörg Schleich, who said that the most sustainable building is the one that you don't build. And I still enjoy referring to this sentence because it's more valid than any time earlier. Because if we really build, then we should do it with the right thought, with the right motivation behind it, and with clever engineering to guide designers, clients, and architects around the globe to find the right approach to buildings. And in our office, we have, of course, a multitude of individuals who contribute individually. But in principle, we can categorize our sustainability approaches into certain fields. And I'm trying to somehow define this as the red line in our in this presentation to show you how this can be seen and found in our projects. We all know that we have to do something because we only have this planet. And as you may have read in the newspaper last week, the NASA thought that they had found another Earth-like planet nearby, which turned out to feature 350 degrees on the surface. So it's not an alternative to our planet. So we need to do something. And one, at least I know personally very well, and who dedicated all his life to such, let's say, thoughts, was Jörg Schleich, as you have heard already. More than 30 years ago, he actually wrote a publication based on his investigations and on his beliefs in August 1989. He asked the question, how much desert does a car need? It's very interesting to read this publication. Feel free to contact us after this lecture. We will send you an English version of it, because the message that is sent in such a publication is, again, more than valid. Jörg even refers to PV photovoltaic cells that are currently under development, that are beyond anything in price, but he foresees that at some point photovoltaic cells will take over. And only 30 years later, believe it or not, 30 years later, you can read it on the newspaper that there are political ambitions to support sustainable strategies to produce fuel based on a more sustainable production sequence, like with solar energy and so on. And that indicates a very important attitude of an engineer, and that's endurance. Endurance to survive, to sustain ideas and challenges for such a long time until they are finally somehow reflected in the public and also accepted. And that, in terms of renewable energies, based on these beliefs that we had from early on, we developed many different principles to harvest solar energy. You can see this chart here, this timeline that goes from early ideas of solar updraft towers, large installations that collect sunlight, heat up air, and accelerate turbines in the central shaft, through parabolic troughs, heliostat systems, and today also photovoltaic installations. So we have come a very long way to support the engineering part, the structure engineering part, by also other engineering thoughts in thermal and photovoltaic applications. So this early idea of harvesting something that appears to be more or less endless, like our sun, has come a long way, as you can see here. This is one project which is under finalization in China, consisting of 15,000 of those heliostats that are individually operated and follow the sun to reflect the sun rays onto the central receiver at the tower to produce energy there. This is one of the latest photovoltaic projects we've been involved at, a tracker project in Saudi Arabia. Now, all of this is associated to the required awareness that we need to invest our time and money into such approaches. And this awareness is also something that we are able to reproduce or to transport into our more conventional building projects and construction projects. We need to educate our environment, our people, our community that the production, the harvesting of energy, storage of energy is something that cannot happen invisibly. And so such landmark projects like this energy storage tower in Heidelberg can be used to remind everybody that a change in thinking has to happen. So our challenge was to find out how we can turn an old gas storage that is not needed anymore into a beacon for renewable energies. So hot water that is produced that can easily be stored in this tower is actually plugged down by this cold water plug in order to avoid evaporation. That helps to reach temperatures up to 115 degrees in this water storage, which makes it even more efficient. This system would be, of course, self-sufficient, and it would look very similar to the gas tower that you have there. But of course, you can't just build such a storage tower today in a city like Heidelberg anymore. So our proposal was to wrap it with a cable facade from which a single-sided supported helix stair is suspended, to allow people to climb this tower and to enjoy a cappuccino in the restaurant on top of 20 million liters of boiling water, which is, of course, a specific adventure. But as Professor Tanton said, safety and redundancy is, of course, key. So there are no issues. But by combining this, the storage and public use, we bring this closer to the attention of people. Of course, there's a deep planning routine behind it, consisting of different disciplines that work together with the heat storage engineers who provide this technology for the heat storage tank, and then our knowledge to produce this cable net. And we take our architects who clearly enjoy the standing, of course, not only in front of the camera, and the engineer behind it, as it is quite common, in the wind tunnel, which we use to predict more efficient and more economic wind loading, but also, of course, any sort of side effects like comfort for people walking around, or any dynamic amplification that could result from the interaction of the structure and the wind. And once this is happened, it also by measures like this, by bringing engineering close to those who only see the architecture, it helps to understand that there's so much beyond it. Then, as you all know, as experts, we also need to take care of the structural engineering and the dynamic assessment. People-induced vibrations on bridges or stairs are, of course, an issue, especially if we try to generate something that hasn't been done before, like this helix, which is supported only within the cable net. And at the end of the day, this approach is somehow a hybrid of physical testing and theoretic analysis, because it is possible to predict it very closely, but there are of course limits. And these limits we are closing with physical tests, which look a little bit funny on the left. This is a bridge that Mike and I developed in Sassnitz at the Baltic Sea on the northern shore of Germany. And our partner Andreas, the guy with the white shirt, enjoys actually participating in this dynamic test, which resulted in the fact that we do not need any dampers. But of course, it has to be verified. And the same thing will happen also in this tower in Heidelberg. And I hope we can engage Andreas, who was not involved in detail in this project, to join at least the testing. The project is currently under construction, and the heat storage is already built, and now the cable net is under fabrication. So it's really been realized. It can only be realized because there is a client behind it who is willing to walk this extra mile to realize such a project, which is for sure not a very common one. In order to develop these projects, we need to understand more about materials, which are a fundamental part of the whole sustainability consideration that we need to wrap our projects in. This may not be too common and too, let's say, too much of a hype in other parts of the world, but it's coming more and more. And in Germany, there's really a hype about timber structures. And what we are trying to implement into this discussion or into this joy of working with a natural resource is to educate and to test the boundaries also, but also to educate ourselves and our teammates with the right application of such materials. Because of course you could build anything you could build everything out of timber, but we need to ask ourselves what makes sense and up to which extent. And as you can see here, for example, at this viewing tower in the Black Forest here nearby Stuttgart, those elements that are mainly utilized by compression and slightly by bending are made of timber. And those structures that are actually somehow in contact with water areas, there's a separation. So the detailing is very important in order to make this a long-lasting and a durable structure. The detailing, as I mentioned, is very important. So we try to stay on board of projects until it is really finalized. We, of course, work very closely with contractors who have to execute these works because we are designers. We do not manufacture that. But if we loosen up the grip too early, then such important interfaces might lose their performance criteria, and that may result in problems, especially at those zones, for example, where the timber touches steel. So cable clamps, which are originating already from a Killesberg tower here in Stuttgart, have been further advanced and further developed. And then the selection procedure starts to select the right timber to produce these glue lumps. And we are involved in this procedure and have intense discussion with the manufacturer to result in these projects. To understand how this works and how we can actually contribute, of course, in a discussion on eye level with all our partners, we have to do a lot of research and we have to understand what's ongoing in other parts of the world. But without contributing a big percentage of our lifetime into this field, we couldn't advance and we couldn't push boundaries. And despite the fact that Mike would be, of course, would lend himself perfectly to explain you more about this investigation that you see here, because it's a field where he is intensely investigating at the University of Berlin. We are closing this gap between university and the practical part. We are understanding what's ongoing in either fields. And here, for example, we look at the comparison of a human hair against a carbon fiber. The thinner one is the carbon fiber, and that element is actually used in a certain embedded in a certain matrix to act as a highly efficient tensile load-bearing element. Here you see one of the first projects executed at the University of Berlin, where the whole team is supported by only 0.5 millimeter thin bands support this concrete elements and the university team. And also other heavy load tests confirm that thin concrete shells with carbon fibers embedded are something that can lead, if the investigation and the research is continued at that pace, very soon to elements that are actually applied in construction projects. Here you see a carbon fiber pre-tensioned thin concrete slab that spans 9 to 10 meters and uses up only a minimal percentage of a flat slab concrete structure. And thinking this further leads to the application in larger span applications like underpasses here that are spanning 30 or 40 meters. And the first specimens have been tested successfully, and this will be soon be embedded in the first projects. But also other more conventional building systems can be reinvented and can be optimized. On the left, you see our cable net supported glass facade at the entrance of the One World Trade Center in Manhattan, where we had the pleasure to work on. And we have reinvented this by swapping the conventional cable structure against a carbon tendon structure, which is actually embedded within the silicon joints of the glass, and that is something that is also successfully tested. Here you see the pendulum test hitting a carbon supported glass, and we are now transferring this from the research state into real projects. So this innovation is guided into the execution, as you can see here, with an early rendering and technical drawing of a network art bridge, also near Stuttgart. That is also still a rendering. And when studying the network arch bridges, especially in relation with heavy individual loads from moving light rails, for example, light rail trains as here, it becomes obvious that the specific challenge that these structures always had was the load cycle to which each of these hangers, especially resulting also from the diagonal installation, was exposed to. You see this in this visualization, how the train passes by, the load passes by, and the load cycle rises, and that may lead to a certain fatigue. At least it leads to an incredible effort in manufacturing conventional steel hangers, and that's why there was a lot of research also guided by Mike's team at the university to implement carbon tendons and to develop the right end anchoring system. Our dear director, Lawrence Haspel, has pushed this limits by far and has managed to realize such a light rail arch bridge. Here you see it under construction, how the arch, very slender arch, is conventionally built piece by piece, module by module. The whole bridge was actually constructed on the side of the highway, a heavily utilized highway. The hangars are installed piece by piece. I must say that the procedure to install those hangars is an interesting but also delicate operation, which requires guidance so that the accurate tolerances are met. But since this is in a transition zone between innovation and, let's say, general application, this is, of course, also something where we learn from and where we educate ourselves in applying this more and more frequently and freely in the following up projects. You see the anchoring detail and the finalized arch on the one side, and then how it was actually prepared to be pushed across the highway in a nightly action. So it took around 12 hours to push it across and to reopen the highway again. And the next day it appeared actually like that. And now all the site works are safely done. The site base and the ramps are being finalized so that soon the structure can be utilized. Jumping back just one image, it's quite interesting that such a project that demanded a lot from us and from our teams resulted actually in a follow-up project for the German railway authorities, where an entirely different ballgame was ongoing with a large-scale application of this for a rail fast train bridge, which is currently under tender. So you see that with the right preparation, and again, coming back to our first term of sustainability, the endurance, it can be managed to still implement change into common thinking. Now, we understand our tasks, and we push our clients to accept reduction, because only by reducing the amount of resource that we embed into the load-bearing system, we can actually claim that we tried to define the most sustainable structure or the most sustainable building. And despite the fact that we know that it's always only sustainable up to a certain ratio. One very beautiful example out of nature or from nature is the shell of an egg. I'm not sure if you're aware, and if you allow me to side address this, Germany is a country that codes every single egg that is laid. This is a very important procedure, because from this code, you as a user, you can understand from which kind of farm this egg is coming. You can even find out the farmer and talk to him directly. And acting as sustainable engineers means also that looking at this from a holistic picture, we need to address this. So we only are allowed to buy eggs that are coded as 0 with organic farming. Please remember that. But of course, I'm not showing this to educate you about German bureaucracy, but I want to show you a very special bridge that was built nearby Stuttgart for a private client. And if we compare the slenderness of this bridge with the slenderness of the shell of an egg, it results in the values that you can see on the right. The egg is around 5 to 6 times thicker than this bridge that was actually built with a span of the lower supporting points of 20 meters and the upper ones with 30 meters, and a stainless steel deck shell of only 20 millimeters. And you wouldn't believe that it was all developed on the balcony of Mike Schleich with his orange net to, of course, not perform all the engineering, but to understand the shape that could be found in the later form finding routine, which you see here. And the idea was to build a structure that only features that material that is actually structurally utilized, and to cut out everything else, which was not by surprise, because it was developed for a client that actually produces and owns these cutting lasers, and who helped to realize such a project. Here you see how every single hole is cut, and with really very special fabrication skills, the workers formed the shell manually. On the bottom left, you can see that. And while our engineers and the experts from the manufacturer still discussed about technical aspects, the hard work and excellent work was actually executed by these workers, who manufactured everything in this sub-assembly zone so that it could be lifted in one piece and could be placed on these very small stainless steel spheres. And this is how it looks today. It connects 2 privately owned pieces of land and crosses a public road. So it's a very delicate topographic and geographic thing. It was beautifully illuminated by our lighting department in our office. And I'm very proud and happy to show you this very fresh picture of my dear friend and partner Mike, who earned and got the German Bridge Award yesterday for this bridge. So you can't hear it now, Mike, but this salutes you. And I think that we all would have decided the same way. Now, it's one thing to develop interesting projects, but it's another thing, and that's actually something that we see more and more in upcoming tenders and in upcoming projects, that the social context is something that cannot be ignored further or will not be ignored further. So we are engaging for example, community managers who speak to the community who are exposed to the construction measure, for example, in order to understand their needs and desires. And this is such a project that was developed with Alejandro Aravena, who is a Pritzker Prize holder from Chile. It was a project which we had to develop for the Inter-American Development Bank in Buenos Aires, connecting two very different areas of Buenos Aires. So Buenos Aires is also a city of contrasts. And on the upper side, you see Barrio 31, which is basically a very poor area. And on the bottom, you see a very, very rich area with convention centers and museums. And the initial idea of the bank to build a high-rise on the rich side, but representing the development character, that wasn't really accepted by the city. And so we proposed a solution that crosses all the train tracks. And if you look at those numbers that you see there, not sure if you can read them so quickly, but in principle, it was possible to demonstrate how we could actually change the possibilities of all the people living in the poorer region, to give them access to more healthcare, to more jobs, and to also cultural and recreational areas by factor 5 to factor 10. And that helped to convince everyone to realize such a project, a bridge-like structure that carries not only the offices of the bank, but also the park, that helps people to transit from one side to the other, because of course the bank didn't want to have everyone pass through their office rooms. For us, this imposed quite some challenges. We went to Buenos Aires to measure vibration induced by the trains, to understand how the foundation needs to be decoupled from the buildings, so that actually an environment can be built for people to use the bridge and to cross the bridge. We will also be more and more exposed to not building on the green field. There's more and more people on our planet, and we need to find new ways how to treat existing environment. We need to reinvent ourselves and our approach to that. So the question of reuse is something that we probably should have asked ourselves altogether much earlier. Looking at such beautiful buildings like the original Penn Station, designed by McKim, Mead, and White, a Beaux Art building in Manhattan, which was actually taken down and something else was built. This is the US Post Office, which is next to this building. And looking at this from the bird's eye view from today, you see Madison Square Garden, multifunctional building, which is there today. And you see the James Farley Post Office next to it, which was, let's say, repurposed by SOM into a multimodal hub for, let's say, repurposing and reinventing transportation in Manhattan, with rising requirements there. The initial proposal by the architects to cover this courtyard was, let's say, following a different route. So we proposed to follow a rather, let's say, a more organic approach by proposing shell-like structures. Shells can be found not only in Mike's Bridge, but also in nature. That's where it's originating from. And that is something that we managed to embed in this. The existing trusses that you see in this rendering had to be kept. They were listed under heritage. And so we did our form finding routines following on these existing geometries. And together with the architects who had very specific requirements of the density of these elements, we developed the shape. We have certain routines that we embed in these geometric optimizations to actually maximize the number of repetitions and to maximize the flatness of the panes so that fabrication is simplified and also economized. And here you see how these nodes were produced, and the shell-like behavior could be generated by these very slender and thin profiles in collaboration with this cable net that is bracing the structure in total. And here you see how additional semi-spoke wheels stabilize these shells against unbalanced loadings. Here, a top view, you see that, of course, not every surface can be generated as a flat surface, and that's why we embedded these quadrangular planar elements in these stepped supporting edge conditions, which were then water tightened and resulted in the final layout. Here you see some shots from installation and a close-up how it looks today. And that gives a very important, or shows a very important aspect of our modern work. You all have heard of the term work-life balance, which was unknown when I started to work, and which I actually also appreciated because it taught me what I know today. But I understand also that we need to adjust, and then we need to adjust ourselves to modern requirements. And these projects help us to engage people of the young generation to invest their lifetime into developing and delivering such venues. You see Hudson Yard, an insanely big project of $25 billion US. We played, of course, a minor role in this overall investment. But for example, we developed the Edge, which is the viewing platform, in the highest viewing platform actually outdoor in Manhattan. And another thing, a facade which is situated in front of the vessel, which is a piece of art by Heatherwick. And the challenge was that this piece of art is not reflected within this art wall, the glass wall. And together with Jamie Carpenter, we came up with this idea of actually curving the glass in a very specific way, which is optically optimized to not reflect the vessel in front of it, but the sky above. And it's, of course, also challenging to produce these curved laminated glass elements. We found a company in Italy who was capable of tempering this glass and laminating it in templates so that this solution was realized, and it looks like this today. And from the interior, it's a very, very much translucent application, which looks entirely different when you look from outside because it reflects the sky. This is possible because we have a large team. So we have some who do what I do now. And then we have, of course, a big group of experts and dedicated people who work in all these different fields: bridges, buildings, sports facilities, and towers, and so on. And that created this global network. And when I joined this meeting here, this webinar, I learned again more about our external global network, which is the most important thing. I'm really convinced of that nothing can happen on our own. We are absolutely dependent on this network, and that's why we have embedded our offices all around the globe. And our team of around 200 people is distributed within these different offices. We meet normally once a year to learn internally and externally. We invite people and experts from other offices and other universities to extend our knowledge and to think outside our box, which is for sure also existent, to learn more about new technologies and to simply also cherish the being together, which is nowadays really challenged by the COVID affairs, but I'm sure that this will improve very soon again. As I mentioned, we developed this program to get together and to test new technology like these HoloLens-based planning procedures. And that helps also to engaging our team, external teams, and to advancing our projects. And that it helps to get the right feeling for projects, for the challenges that we are facing in these projects, and to generate the right courage to develop something that starts with a first idea, with a model that is maybe close to the final solution, but which is not necessarily thought through and which is not necessarily feasible to all aspects. But we need this drive and this courage to finally have our people with their feet on the ground to guide installation here of the Wanda Metropolitano, an amazing and very large steel membrane cable roof structure covering the roof of the pitch on which Atletico Madrid fights against the other teams in Spain. And these large span roofs, they starting from a certain dimension, they become more and more economical and efficient with, in case we base them on cable structures as this one. So in this case, there are actually 3 outer compression rings, the wide structure that you see in the background, and 2 inner tension rings, which are connected by 2 alternating ridge and valley cables. Here you see the preparation for the cable lifting. The ring cables are placed on the ground, and then a concerted simultaneous lifting procedure, which is based on hydraulic lifting equipment, is planned with geometric force charts and associated forces to understand each of the lifting steps. The video that you may see here, I hope that it actually that it works. This is of course not Madrid. You see there is snow. This is in Warsaw. But talking about snow, I must say that in Madrid this year we had the 100-year snow event. It was a very special weather event, and it of course challenged the structure of the Metropolitano Stadium significantly. And that showed us that it is very important to guide also such a building along its lifetime with presence, with physical presence, with and with maintenance and with all these things to fulfill the lifetime. And we design these venues to 50 or 100 years, depending on the codes and the requirements of each country. So and that, of course, gives also us joy, because we invest our lifetime in delivering these venues. And when you are finally there at the opening day, and this is now really by surprise, because I was there at the opening day with my kids, and Mike was also there. And we both enjoyed it very much, because it was a very long procedure to develop this project from the first sketch to final handover. And that is a very similar experience as we both had in India, a country that formed us, I must say, to what we are today, for which I'm very grateful. Here you see the opening session of the Commonwealth Games, a very, very special event to us. I know there was a lot of discussion about it, But let's say from an emotional part, this was a life changer in my life, because yeah, more or less for the first time, I was really fully responsible for the delivery, and sitting there and seeing that is of course a reward for something that started differently with, let's say, being exposed to a new environment, to a new country like India. When I moved there in 2006 and lived there for quite a while, first in Calcutta and then in Delhi. Of course, I had good friends and good guidance with many very close friends and mentors, as you can see here. Of course, Mike Schleich, who helped me to find my way into your country, which I considered then being my country as well. And Jörg Schleich, you see here in the middle, was a very special tie to India as well. And I'm for sure going to miss out some, please excuse that. But Dr. B.C. Roy, who is here, I'm very grateful for the many years of collaboration. Dr. Bandyopadhyay, Dr. Chatterjee, many more, and my very close friend TK Basul, who you see on the right here, who I owe so much, and who helped me to and us to do the independent checks for this second Vivekananda bridge. You wouldn't believe how much we learned there. I learned there, and I transponded all of this into other projects like the Commonwealth Games in India. Here you see my first, let's say, puja that was done to bring safety and happiness to this new project. And I must say, I'm enclosing this now, I must say, 13 years old images into so many early project phases of my current projects, of our current projects, because it shows dedications and it shows that nothing is impossible. You see how different the challenges are in each country and in each project, not only technically, but also culturally. So we were facing, for example, to save this ancient tomb and to guide not only the foundations and heavy loads around it, sorry, but also to bypass the evacuation ramps of the modern arena by it. And then, of course, also to understand and to get used to fabrication capabilities and understanding of different areas was also something that we had to understand. And on the first day, when the first truck arrived on site in Delhi and they dropped these metal sheets, I actually was a little bit lost because I didn't know what to say or what to do. But then we decided to to start on the premises with the fabrication yard and to embed our knowledge and to combine it with the expertise and the knowledge that was there, which was profound, and to start fabricating all the details and all the connections on site, which is unbelievable in my eyes. And it turned out to function in principle the same way as we had seen it in other countries. You see, for example, dye penetration weld tests. You see tolerance checks, the guys on the right. We embedded our trial assembly philosophy, which means that we put next to each other certain elements of, for example, in this case, the compression ring. And by producing a larger scale specimen, we can more easily test and verify the geometry. You understand instantly if there's a certain offset or not in whichever kink, and then you can correct this angle at this location. And this is what was done on site with the newly procured machining device. Then the trial assembly was redone again, and the tolerances were measured and once they were met, the whole thing was installed, and that was how it was actually handed over. And so this project combines so many of these attributes that I have exposed you to now, and it guided me also to my next adventures that we were responsible for in Brazil, for example, and also in other countries and other cultures which require different adjustment. Challenges are happening, like this, for example, where the last member of the compression ring of Maracanã actually hit the tunnel sidewall and not the side. Of course, it had to be repaired significantly before it could then be placed within the structure. But this transition from a first idea and from a first rendering into a venue that is delivered to site and inaugurated then is really something that rewards all of us for all the efforts that we had done. Technical optimization or form optimization is a feature that helps us in reducing not only the quantities, but also, of course, in optimizing all the associated, for example, performance criteria that a venue or a project will have. And the Valencia project is something that, that resembles that. The client had actually started this project years ago before a significant crisis had struck Spain. And after the crisis, the project was restarted, but of course the budget was refined, and we had to develop a system that is capable of suiting to this already built environment of a bowl, which is already there, of using the same foot points, same foundation capacities, but simply costing less. And so we decided to kick out simply everything that is doubled. So you heard me saying that, for example, in Atletico, we had 2 tension rings. Here we have only 1 tension ring. In Atletico, we have 3 compression rings. Here we have only 1 compression ring. And that comes at a price, of course, because we are, on the one hand, reducing quantities and structural, let's say, resistance. But of course, we cannot compromise on safety and on performance. And so we have developed specific optimization routines that help us to understand the specific behavior of such a, let's say, more flexible structure. And we are combining the effects that we learn with the functions that such a roof has to have anyhow, like this catwalk with all the embedded floodlights and public address system and video boards and so on. And we can actually hide technical equipment, structural technical equipment that we need inside. Here you see the cross section of the catwalk. And there we embed tuned mass dampers, which are specifically developed towards the response of our roof system that we have here. In order to understand this, we perform dynamic assessments in the wind tunnel to understand what's the dynamic response of the roof with relation to the structural system and the exposure of wind effects and so on, and how we can compensate these effects by embedding the tuned mass dampers. And that helps us not only to reduce the response of the roof, but also to reduce the loads through which it gets even more, let's say, mass optimized and through that sustainable. Some projects start with a dramatic scenery and with dramatic challenges, like the ones where we where we landed in Qatar and where we started to look at when we arrived there many years ago. There was the challenge by the emir, who wanted to receive one of the 8 venues, reminding him of his heritage as a Bedouin. So the largest Bedouin tent in the world had to be designed and developed. And I could speak a lot about all the things that we introduced into this project, where we worked as the lead designer with retractable roof and so on. But I only want to focus on one specific aspect, and this is the inner liner. A Bedouin tent is a structure that is actually very clever and highly performant, because it features multiple layers. It's very comfortable on the inside during the hot days and the cold nights, and it's very safe against storms and so on. So we studied the fabric out of which basically the heritage of the Qatar Bedouins is made, and we translated it into a modern application, not only the pattern, the Sadu pattern, but also the way it's produced. And first we received proposals to actually print it and to apply, let's say, printed sample specimen on fabric, PVC and so on, but we didn't convince us. And so we searched on, and we found a century-old fabrication technology, which is called Jacquard. It was a very clever guy who invented this weaving machine, and with the fabrication skills of a French membrane supplier, we managed to produce our own fabric with our own pattern. And this pattern or this fabric, of course, had to be tested to show that it's structurally liable and viable, and that it also is fire resistant and so on. And after digitalizing the pattern, we actually started to weave this in large quantities. Here you see how the raw material is produced and rolled. And then here you see that more than 70,000 square meters of this material was projected to be embedded as a new material in this new venue. And for that, of course, you also need a client who takes the risk of working with a new material. Here you see the patterning, fabrication in Turkey, the rendering, how it was envisaged to be looking. And this is a photo that we took a few months ago of the interior and the exterior. And what it does is actually pretty interesting. It helps to not only regulate the climate inside this building, because now it performs similar to a Bedouin tent, but it helps also to optimize the acoustic performance by this perforated surface, so that sound can actually enter into the space between the outer and the inner membrane, and then can dissipate better than being reflected from a closed surface. So this is how it looks from the outside, embedded within this desert. Now, we are fully aware that there are ongoing discussion, and they are, of course, also up to a certain extent reasonable, and especially in relation to large-scale events within individual countries. I must say that it's not right to listen only to one side, and I think we as engineers, we bear a very big responsibility to expose ourselves into this discussion and to join this discussion. And through that, we can actually, let's say, influence the development. And what my experience is in your country with 5 years from 2006 to 2010, which changed my life and made it better. But also our whole South American experience, where our teams were self-responsibly operating and developing these venues in different cities. For example, in the city of Manaus, of course, if you look now into Manaus, you see a venue that is not heavily used, but that is a question of the operator. But the people of Manaus, the people who live in that city, they felt respected by being visible to billions of people who actually watched the World Cup in 2014. And that is something that is an important component of the overall discussion. Of course, it's not individually valid. What you see here is another stadium that did not, where the operators did not manage to find another use. And to be very frank, also some of our venues, like this one, for example, in Brazil, a wonderful, wonderful venue at the axis of the monuments designed by Niemeyer, is actually standing there unused. It is mesmerizing to be in this building, but of course it's also frustrating to see that these venues are remaining unused or are built for a certain purpose and then are not used anymore. So when we were hired to develop the Rio Olympics, we specifically developed a venue that can be taken down and can be reconfigured into a new configuration. Unfortunately, also there, it was obviously not clear enough what the ambition was, and this is how it looks today. Some elements have been repurposed, I would say, but not to the purpose that we originally thought of. So this aspect of the social component of these projects and the capability of looking at these projects from a different perspective opened our eyes and let us rethink, let's say, the global large-scale event industry. Of course, we had the knowledge of all the components that we need to embed into such a venue. And this is also part of our business. Don't understand me wrong. We can't I can't claim that I would be happy if none of these large scale elements would happen anymore, but we need to contribute to make them more sustainable. And we studied other large scale elements for events, for example, this concert in England, where normally 350 cows live, and then during a few weeks, 200,000 maniacs celebrate and party. And the post-event, after a little bit of cleaning and repairing, the cows are then brought back. And that showed us that we need to somehow embed this thought into a demountable stadium based on a kit of parts which can be transported and plug and played. Yeah, like in earlier days, the circus would actually hit town and would bring entertainment. We would actually translate this into the modern entertainment industry, which is very important, as you can all see now with the pandemic, where people go wild because they are not exposed to joint cultural events anymore. And there are millions of unused containers from the shipping industry, and they can be repurposed and can be stacked basically in large-scale shelves, which are based on a modular system. So each of these elements of the columns and of the beams and of the slabs are identical per sector. The boxes, the containers are pushed inside. All these components are mountable and demountable, and can, by bolted connections that are of course designed so that they can actually be reopened again, so there's no plastification in the bolts, can then be equipped within the shipping containers. Also the MEP equipment is inside the shipping containers. And then the whole venue, after hosting the event of the FIFA World Cup in 2022 in Qatar, can be repurposed, can be reconfigured in different legacy modes, as you see here. And in order to be better than in Rio, we proposed already different stadia or arenas, multi-purpose arenas that can be built out of that. And here you see how we thought of this structure. It's a very, very simple configuration. It won't win the Pritzker Prize for the most beautiful architecture. For me, it symbolizes the beauty of structure because it is wonderful. It combines so many aspects of a sustainable modern building, and so it resembles the pure beauty of structures, as I want to somehow bring it closer to people and clients. It is located at the most expensive location in Qatar, and of course the client is happy to demount it afterwards, which is also an important aspect, that there is the requirement to take it down, because if it's on a cheap piece of land outside, it wouldn't be so important maybe. Again, wind tunnel, and then fabrication starts, and this is the skyline of Doha. in front of which our venue is rising. Every single piece features this QR code so that you can locate it in the BIM model and can place it basically on site. And very simple pad foundations, they of course have to be removed manually afterwards. Here the shelf is rising, raker beams, and here the first containers are already on site. These silver closings are the temporary nature. They are just there to allow that the shipping containers are transported open bulk on a shipping container ship, and then later this will be open so that these containers are linked. Upper tier is already there, and you see how these containers are fixed on the beams. Roof girders are placed, everything modular. Also the roof girder can be split in two and can then cover two half-deep later legacy roofs or legacy stadiums. So this is soon to be finalized, and I'm really very, very happy that we managed to convince the client to do this. You must know that this project is one of 8 that is being finalized in this country. It could only be built because the organizers are actually had reconsidered their sustainability approach and reopened the competition. They canceled out one already decided design and build project of a conventional stadium and replaced it with this temporary venue. They convinced together with us FIFA to accept this as a first temporary venue for such a large scale event. So this is a landmark for future events. So this flexibility brings me to the last part. I hope that you're still awake. Sorry for talking so much, but it's also a part of this emotional engineering that keeps me talking. And so this flexibility is something that can be embedded in venues and buildings and structures in general in different options. Here you see, for example, the Commerzbank Arena in Frankfurt. It's a stadium, soccer stadium, which can be transformed into a large multi-purpose arena. And now this is the Warsaw Stadium, which is another venue which features this retractable roof. Designed differently, it's designed for more snow load and so on, but it actually helps to deliver the project also for multi-purpose applications. The whole video screens can be lowered, and here you see the Vancouver Arena, which is another stadium that received one of our retractable roofs with a inflated cushion. This inflated cushion was required because the snow loads reached up to 270 kilograms per square meter, which is incredible. And a single layer membrane would have shown some ponding, but altogether they follow one. Not only have sports entertainment shows there, but to feature different things. The Dalai Lama visited the Frankfurt Stadium. There are sport intercoms, rock concerts, box fights, and stock car races, and whatever operators, and that's the important term, come up with. So that is something that we are trying to implement in our projects. Also, the technology can, of course, be seen in different other projects like folding bridges, folding roofs, and or folding solar mirrors that reflect the sun. So different disciplines educate each other, and we can help to make our projects and also the projects of others more advanced and more evolutionary. So we, as engineers, as I mentioned in the beginning, we of course work in a team. So we produce basically ideas that can be embedded in different projects. We don't want to impose architectural solutions on our clients. We want to guide them to find their own solutions, which of course is also our solution then. And we do this by developing physical models, by building physical models, or running computer models more and more that simulate how these folding mechanisms of these retractable roofs might work. On the middle right here, you see, for example, the Real Madrid stadium that's currently under construction. And on the bottom, you see the simulated Warsaw Stadium and the real-time Warsaw Stadium. And that helps us to benchmark our computer models to be better during the next time. This is a project which is very important for me as well. It is the competition win for the cover of the Arena di Verona in Italy, a competition that requested the proponents to develop a roof that can be entirely retracted in case it's not used, because of course those who go there and who witness an opera or concert, they don't want to see our roof, they want to see the clear sky and the stars over the arena in Verona. Unfortunately, there's a lot of rain and many shows fail, and that's how the organizers decided to increase their revenue by having this multi-purpose feature. And we proposed a roof that features this outer compression ring and the parking garage, where not only the membrane but also these cables are stored, and that helps to not see anything when not used. These principles are more and more embedded in conventional buildings, as you may see in some regions in your country as well. This one is another project in the desert, and it was the first courtyard that was planned to be used also during summertime, so where locals can actually sit outside and enjoy tea and coffee and dinner and lunch during hot summer days, which is of course impossible without engineering. We joined a team around the architect Michel Moussessian and climate engineer Transola and our engineers who developed this idea of creating a cold air lake underneath that is protected by retractable roofs above. You see this 90 by 35 meter roof, which is actually powered in such a way that it can follow the sun and can shade off areas that are exposed to sun. And in case it's not required, it's stored safely in the parking garage. And this is how it looks when it's fully closed. And we are very convinced that these multifunctional features will be seen more and more in projects around the globe, because they help to repurpose also buildings that would otherwise maybe be taken down, and that helps to reduce the footprint that we continue to have on our planet. Yeah, ladies and gentlemen, I'm sorry that I spoke so much and that I took 1 hour and 11 minutes of your lifetime. Maybe you found something that interests you. Feel free to contact us, and you can have a look at our documentation. We have, let's say, regular publications, books about our build projects or our solar projects, or get in touch with one of our subsidiaries. And if you have any questions, I'm of course more than happy to respond to those now. And that's the end of my presentation. Thank you very much. And again, my apologies.
Thank you. It was an excellent, amazing, fascinating presentation.
Thank you.
Professor Tandon, you are on mute. Kindly unmute yourself.
Professor Tandon,
I just got a taste of my own medicine. I asked everybody to keep themselves muted, and that's how it was. I remained there. So, Mr. Kanut, I think, is obviously a very emotional person, and we must thank him for making us a part of his professional journey in life itself. I think that what have we learned from this presentation? I think there are many things, and some of the things that come to my mind are the synthesis of the structural system and the visual form. They both are, if you can somehow correlate them, the structural system and the visual form. I mean, that is, I think, the height of structural engineering that you can reach as far as beauty and sustainability is concerned. Structures derive their beauty and sustainability not only from their pleasing appearance, but economy of material usage was one thing that came out. Also, where the flow of forces in the structure are self-evident, the appearance can be most enchanting and give joy to the onlooker, as we have all experienced in the last 1 hour and 11 minutes. For sustainability, the structural engineer must think also of the sociological environment in which we are designing structures. Actually, reuse, recycle, recreate, reconfigure, these are some of the words that come to my mind when I look back on what we have heard today. So now we have a very eminent panel to say a few words and also answer the questions that people have put in the Q&A box. Let me just introduce you very briefly to the panelists. We have Dr. Professor Mike Schleich, who graduated from ETH Zurich, that's in Switzerland, and he joined Schleich Bergermann Partner in 1993. And his father, Georg Schleich, was the person who had established this organization. He has been a partner since 1999 and is currently the managing director. He is a certified proof-checking engineer for structural analysis and a professor at the Technical University of Berlin. And he is the chair of the conceptual and structural design. Then we have Mr. V.N. Hegde, presently Chief Executive Officer of Stoop Consultants Private Limited and former Executive Director of Gammons. He is an astute strategist and a senior professional with a rich experience of over 3.5 decades in the construction sector in the areas of design management, technical management, construction management, project management, and contract management of specially engineered structures. Finally, we have Mr. Alok Bhaumik. He also, I think, doesn't need to be introduced, but let me remind people who he is. He is the current president of our association, Indian Association of Structural Engineers, and the managing director of the well-known consulting firm, B&S Engineering Consultants Private Limited. He has more than 40 years of design consultancy experience in transportation infrastructure. He has an accreditation of International Professional Engineer, India, and is a fellow of the Indian National Academy of Engineering. He is also currently the chairman, editorial board of the quarterly journal Bridge and Structural Engineer, which is published by the Indian National Group of IABSC. I think we can now turn to the questions and answer session. And finally, of course, I will request Professor Visa Lakshi to give a vote of thanks, but that is far off. Let us first go through the question and answers, which many people have put. I think we can, I'll try to read out other than those which are only congratulatory and laudatory. because I think that we need to discuss something more than that. Everybody agrees that it was indeed a remarkable presentation. So coming to the first question, Dr. Sushil Dhawan, how are these beautiful structures durable? Is the first question to you, Dr. Kanut. And if you feel like, you're most welcome to divert any of these questions to your panelists.
Thank you. Well, in principle, the durability of a structure or a building consists of several aspects, and it's first of all linked to a thorough and detailed design and the right application of materials and combination of materials that we all know. But we need to consider, or we have a very specific assessment of how to combine and compose the different materials so that there are no conflicting, for example, pairings of materials and so on, and that the corrosion categories are specified properly, and that, for example, with the cables that you have seen more frequently in the past presentations, they receive a special zinc aluminum coating, which warrants a 50 years lifetime without required further touch-ups. So they, in principle, become a very, very redundant and durable system. The durability is, of course, also resulting from the performance of the structure. That's the second aspect. So, for example, vibrations or movements or dilatations or whatever, they impose certain challenges on either the global system or on the connection, and that is something that has to be thought through carefully, because otherwise, if you have a weak link, this will always be the starting point for problems. But these are aspects that where we, let's say, have more responsibility and control upon. And then there comes a very important aspect, and that's maintenance and the guidance of the building. And I tried to mention this once, and we are all not shy, and we are not getting tired of reminding the owners and the operators of buildings and structures worldwide that it is their responsibility to look after their building. And it is irrelevant if it's a public client or a private client. You need to look after your stuff. And so that means that, of course, we develop, for example, guidance and maintenance manuals and these things, how to actually follow such a building in its lifetime. And we guide and educate people what is actually a normal, let's say, timely behavior of structures. So there is, of course, a patina, or there's a certain corrosion, which is not a structural problem. But at some point, you need to go there, you need to repair it, you need to touch it up in order to avoid failures. And we all know that these failures happen, and these failures will happen again if people don't do their homework. And so it's also, I believe, all engineers' responsibility to remind maybe non-engineers and owners that they have an obligation. You know the German TÜV maybe, and so Germans are very strange, as you know. So we have to not only print data on our X, but we also have to bring our cars to the TÜV every 2 years so that they sign off that your car can be used on the streets. In principle, this is annoying, but on the other hand, this is very meaningful, because damaged parts are then located and you need to replace that. Otherwise, you can't use your car anymore. And the same thing should happen with buildings, in my eyes, because there is risk and danger, of course, at hand. But to answer just your question, with the right planning and with the right choice of material, these structures can live forever.
I'm so glad that you touched upon the fact that you give a maintenance manual for all the beautiful structures that you build. I think that is one of the most important issues which has come out in this interaction. Is there anybody else in the panel who wants to interact on this particular issue of durability of such beautiful structures?
Now, Shall I?
Yeah, please, Mr.
Yeah,
Hegde.
yeah, I'm
Yeah.
Hegde here. I'll talk about this durability aspect of this beautiful structure. Before that, I would like to make some comments, if you permit me, Professor
Sure.
Tandon. Yeah, yeah.
Sure.
As a panelist, you see, before the start of this webinar, I was just asking Professor Slice. I'm very curious to know how this topic of the beauty of the structure is going to be addressed. He told that you're going to enjoy it. That's how it's going to be addressed beautifully. It's very fascinating that K. Nutt started his presentation with the beauty of the structures, with the sustainability. When he started talking about the sustainability, especially in terms of the solar energy, I was, brought back or driven back 35 years back, where Dr. George Slice used to very passionately talk about the solar chimney of almost around 1 kilometer. I still remember he was trying to find some, like the clients to propagate the idea of the solar energy of 1 kilometer chimney in India. And if I'm not mistaken, that's what is culminated into reality in China. Am I right, Kenneth, that that solar energy's concept is being used very extensively for the sustainability point of view? That's what I understand. Right?
What is correct is that it is actually the cradle of the solar technologies that found their way into realization. But unfortunately, this specific tower was built in Manzanares as a smaller testing facility, but the 1 kilometer tower was never realized. We are still there is still the hope that at one point we will be realizing it. But as you've seen in this chart with the chronological order of the projects, there are many more technologies which have taken lead nowadays.
Yeah. So also I was to tell you that I was reminded of one of your colleagues, Matthias Wiedemeyer. Like he also used to very passionately involved in the fabrication and erection of the signature where I was involved. His immense contribution, he used to so beautifully as well as passionately get involved in the fabrication as well as the erection of that bridge. I don't think without him that bridge would have seen the reality today, to be honest with you. I could see the same passion in you when you are talking about the fabrication. You are not sure whether the fabrication is going to be done properly or not. It's really, really interesting. For me, it was always an intriguing debate between whether the aesthetics or the beauty of the structure is an art or science. Your presentation today has put me more questions on that subject, whether the beauty is a aesthetic beauty or the aesthetics is a science or an art. Again, that question is become more pronounced as far as I am concerned. Really, it is beautiful. And I remember, like that Robert Maillard's the bridges, which has been, like basically sort of form finding by flow of forces, where exactly the structure was sort of conceived exactly to the requirement of the flow of the forces, and that became, the aesthetically marvelous or the beautiful structures. In fact, those structures, again, you are talking about, like that nature of the shells which has to be found and the shell formation in the nature. And you remind me of, talking about the golden section rules of the Greece. They were also talking about, of the structures which are all pervasive in the nature. They used to form the golden section rule, whether it is forming or not. They found the beauty in the golden section rules. What they call it as irrational number 5. You must be aware of it. I am again reminded of another a very elegant structural engineer, Christian man, who took it was said that the science of the structural engineering he has taken to the level of the structural art when he has designed the Sunnyberg Dandal. But today, after having seen your presentations, I am more and more convinced, as Professor Tandon said, that the form finding by flow of forces, even in the modern era, like the way you people are doing the research on the material side, and also the models, and ultimately coming to the form finding the form by way of the modeling, by way of the analytical modeling, and then coming to the use of your tensile membranes, compression members, and all it again boils back to this form finding by flow of forces. And you are again proving by adopting this form finding by flow of forces that is also sustainable, because you are going to have a minimum material, quantum of the material, when you adopt the principles of the form finding. And also, again, I'm reminded of your Jock slides, where in one of the books, I remember that the light structure, he talks about the light structures. He says that the light structures are sustainable structures. And also he says the aesthetics and the elegance comes from the lightness of the structure. You know, I remember this, that of course it was in German, but I saw the translation in one of his articles of Mike Slice, where very gets, I could not get the English version of Jock Slice's book, but I could take it from one of the translations which has been made by Mike Slice in one of his paper. So I am reminded of that. So it was a beautiful presentation, in fact, and it gave me a lot of enlightenment into the beauty of the structures in a modern era, how the structural beauties has been derived. Now coming to the durability of the structures, as you rightly said, all the structures these days have been designed for minimum of the 100 years lifetime. And all these materials which have been used, I'm sure, and that requirement of the 100 years lifetime has been proved. And after having proved that, only the design of the structures has been done. So that's what I feel. And from that point of view, I think that these structures are durable, Professor Tanna. Thank you very much. Excellent presentation. I'm sure that many more panelists, including Mike Slice, also is going to add his comments on this.
Thank you, sir.
Yes, Dr. Mike Schleich, would you like to comment on the subject we are discussing?
Oh, yes. But first, Alok and Professor Tandon, thank you very much for inviting me to the panel. And congratulations to my partner and friend, Knut Stockhusen, to this really inspiring talk. I mean, it was a burst of pride and joy of engineering, wasn't it? Makes us all feel proud, no? This is the stuff we can do, isn't it?
Amazing.
And it was so full of messages, as Mr. Hecke has already summarized. You know, it's like that the issue of sustainability is really not, as Knut has said, an empty word. It has caused a paradigm change. We cannot and may not design without having that in mind. And as Mr. Hecke has said, lightweight structures is one of the keys to this issue. It's one of the solutions as we minimize the use of material. We don't use our resources, and therefore we are sustainable. I mean, we all know that already, but we should repeat it all the time. And what I found an interesting message is that there's always problems. And we as engineers, we can produce solutions. We should not despair. Like these network arches had big problems of fatigue. But then Knut has shown the network arch with carbon fiber hangers, because carbon fiber hangers have no fatigue problems. All of a sudden, these huge hangers become very tiny and economic at the same time. Or look at the Ras Abu Abud Stadium. I mean, this is a wonderful idea that you guys came up with, another container stadium, reuse. So I think there's so many solutions we can come up to make it a better world, you know, and not only talk about it, really do it. And I think that's why I like these examples. And also I want to talk about durability. Definitely, if there's no good design, you get water accumulations, you get ponding, you get all kinds of trouble. But this is why we need well-educated engineers. And maintenance is definitely, I can only reiterate, the most important. If you don't maintain your building, it won't last long. But I think also at Schleich Bergmann, we are dealing a lot with reusability. You know, if you design your structure so that even if it does not last so long, you can dismantle it and reuse the material or recycle, upcycle the material, then durability can be defined in a completely different way. We should just not produce waste. So I think that's also an important issue that we're discussing intensely at our office. And finally, talking about beauty, I can only repeat what my father says. You know, the big advantage of us, of our profession, of us being engineers, is that we have two legs. We have this leg that is solid basics, the theoretical foundation, the scientific foundations, all the knowledge we have, and that is combined with the other leg, which is the creative part. You know, all we do is create, and there's no other profession that so nicely creates these or combines these two legs. You know, and this is where our structural beauty can appear. You know, and I think Knut, you have shown this so nicely. Thank you very much again.
Okay, thanks,
you, Mike.
Thank you, Professor Schleich. Alok, you have not spoken yet. Please break your silence.
I'm spellbound. I'm spellbound by this very fascinating and very inspirational presentation. I think for structural engineers, this kind of presentations, definitely motivates one. Very impressive engineering solutions, and it shows some of the he has also shown me provoking structural arrangements, various types, whether it is a permanent or demountable structures. So my takeaway from this presentation, many, but I think I will just highlight one or two. Firstly, what Mr. Stockhausen presented is a perfect example of academia industry interaction, which we keep discussing, the lack of which we keep discussing. But I think what all these structures that he has shown, it's a perfect example where the research has been brought into a very logical end in actual execution of the structures. Second, another thing that I found in his presentation, one focus was common, which is the presentation reflected, a very deep technical insight where the innovations are all sustainability driven. I think he has collated all the presentation in a manner to show that how important is the concept of sustainability today, and it is very apt today, when in the present times. Another thing which I liked very much is one presentation where we have a perfect mixture of modern digital technology, how it can be used, but at the same time the deep rooted understanding of flow of forces also is very much essential. I think most of the other presentations that we see either is a very highly technology driven presentations which goes above the head of the normal common middle level engineers, and this, or we see very fundamental things which are deep rooted but without the high tech. I think this is a very perfect combination. Now if you permit me, I have just one question to you, Mr. Knut. That is, I'm sure when you do this kind of innovative structures, you face many challenges. And particularly, I'm interested to get your views on how you face the challenges, when you come out with this kind of innovative structures. There are stakeholders, challenges from the client who may be worried about the cost, or they would be worried about the risk that you will be taking, because you are doing something absolutely new with no parallel. How do you also tackle the challenge from the design checkers who will be looking for a code compliant design, whereas you are doing something absolutely new? And what about the contractor who may find your ideas difficult to construct? How do you push through these beautiful innovative structures through all these agencies?
First of all, thank you for your kind words, and again, it's very important for me also to understand how you reflect such a presentation. So I'm growing with the comments that I received. So I'm very grateful for that. Your question was multifold, and I hope I remember all the components of it. But first of all, of course, let's say the client designer interaction is something that is fundamental for advancing such buildings or such projects. And so there has to be an open discussion to understand what are actually the expectations of the client, because ultimately the client pays for something and he wants to receive something, and it's not that we go somewhere and say like, hey, I would like to build a bridge here, and who pays for it? So this is all a result of a certain tender procedure or of a competition or so on. And so first of all, we need to understand what is actually expected from us. What are the driving boundary conditions? What's the budget? What is the technical framework, and so on? And based on that, the solution is, let's say, starts its journey in development and execution. And then what we do is actually of course we challenge ourselves and we challenge codes, but we understand we truly respect codes, and especially those who stand behind the codes, because they are made to act as a guideline and to but you still need your own knowledge and experience to interpret the codes and to apply the code correctly. It's not like a you can't apply it one-to-one in all cases. You need to interpret what is meant by this sentence or what is meant by this factor, and how does this factor apply to the challenge that I have. And that's something that I think has to be taught. We do this internally in our office, but at every university the base is set for that. So this is fundamental in my eyes. And then the contractor interaction. See the projects. Basically, there's an evolution of projects. If you would look at all these projects in a chronological order, yes, which is not given here in this presentation, of course, this chronological order. It's rather order by themes or by emotion or whatever, and or by attribute. And but if we would do this, could be interesting to do this actually, then you would see how everything is based on an experience from another project. And so we are of course sometimes doing something that's never been done before. Yes, like this new fabric that you've seen in this Qatar stadium, but it's based on the experience that we have of square millions of applied membrane before. So we know where the devil sits, and we know at which aspects we have to look. And so we combine proven technologies in a new manner. And when I say I never mean myself, I always mean us as a team. And when we talk about us as a team and our projects, this is also very often based on something that other experts from other former days, for example, or from other offices have tested. So we cherish this expertise and this community that we are in. So it's all these projects are in a certain way also an homage. But Mike is an expert in this, so he has also lectured several times on the homage. I'm basically, by mentioning that some of these aspects I mean as an homage, it's also an homage to this aspect of developing projects. So yeah, I hope that this answers a little bit different aspects from your question. Mike?
May I add a comment?
Yes.
Yes, please.
I fully agree with Knut, and I think this client and contractor engineer interaction is very, very important for the success of a project. And there's two important words, and I think they are trust and collaboration. Now, if you develop a situation of trust and collaboration in the team, which is the client, the contractor, the engineer, then I think you're bound for success. And this has got to do with win-win situations. One wins if the other wins. You help each other, you push each other forward. I think that is one of the secrets of these projects. And I think, again, I can look back to India. It's the late Dr. Subbarao from Gammon, together with my father, who came up with this win-win situation for the Vidyasagar Setu bridge, for the second Hooghly bridge, which was a world record bridge. It was the first cable-stayed bridge with a composite deck in the world. And it was because the contractor and the engineer worked so well together, trusting each other and collaborating. This is what I wanted to add.
Okay.
If I may,
Yes,
just
please.
one more
Yes,
comment, because I remember now, Mr. Alok, that you also asked about price and cost, and how do we manage that? I mean, we are equally exposed to competitiveness, not only in our design fees, but especially in our construction budgets. Most of the projects you have seen are either equally or even more competitive than a conventionally structure would be. Let's not forget that, for example, if we talk about the Wanda Metropolitana Stadium, it's 45,000 square meters of free spanning roof. If you build this with a steel truss, then the tonnage and the cost is by factor higher than if you base it on this, let's say, light structure that Jörg Schleich also referred to all the time. And then there are projects which are not meant to result in the most economical solution, but maybe they are meant to push boundaries or to showcase fabrication techniques. And if I may say, Mike, the Trumpf Bridge is an amazing piece, and but if you build a truss 3 meters high, cross spanning 20 meters, it's going to be cheaper than the one that is standing there, but it would not showcase the things that are showcased there. And of course, the fabricator, who was a private investor, showcases also his tools that he sells actually as fabrication tools. So there are different motivations to reach different goals, but and to that we need to respond.
Okay, thank you. I think we are coming close to the end of the time allotted to us, and with the permission of the organizers, let us take 15 minutes more to at least address some of the questions which have been asked by the participants.
Sure.
Before going any further, I would like to say that we have as one of the participants, Mr. Amitabh Ghoshal, whom I think one of your photographs also showed him, if I'm not mistaken, and he says hello, and he asks a question. It was interesting to recall the Nivedita Bridge. What are the special care needed to ensure longer life of cables, as they can be most vulnerable element?
Mike, would you?
Yeah.
I did not. Yes, the cables are the most vulnerable elements, and this is again the question of maintenance. You know, maintenance and good design is all.
And maybe to add, no matter where such a structure is located, you need to look at it. And if there's an ISO standard for maintenance, for example, which defines 1 and 5 years intervals for smaller and really intense and large investigations and tests and so on, and if they are not either executed, or if the recommendations that result out of these investigations are not followed through then by the operators and responsible parties, then there is a risk rising. And yeah, that is in principle all we can say. We have one of your earlier sessions spoke about the fate of the bridge in Italy. And that is such an example. I mean, we all need to be alerted that we need to either look ourselves, or we need to guide others so that they look and that they bear their responsibility of either looking and checking, or hiring experts to look and check and repair.
Yeah.
Okay, thank you.
May I add one comment?
Yes, please.
I mean, we have the advantage of having monitoring systems, and if monitoring systems which produce a lot of data, which can overwhelm and drown you, but if you carefully use this big amount of data, this can also help you with maintenance. Like, I would like to also mention that there's another recent example, the signature bridge in New Delhi. Mr. Hegade was involved, Harsha Subbarao was involved, another team play, which had lots of trouble, but eventually we made it a success, didn't we? And this is equipped with a monitoring system. So if you have a good monitoring system, again, if you maintain the monitoring system, I think this is also a very important issue today. We have much better means today.
Yeah, thank you. There is Mr. Vipul Ahuja, who's one of our star structural engineers. And his question is, in the stadium, how do you scale down the tuned mass damper for the wind tunnel study, or whether you actually model the TMD in the wind tunnel? Also, how do you optimize the location of the tuned mass damper? So his question revolves around tuned mass dampers.
Yeah. I mean, first of all, it is a numeric operation to build this hybrid, let's say, system, and also understanding of the structural model that basically is a simple model that responds to the loads that you apply in it, and then to the dynamic response that this structural model can generate with, let's say, changing impacts. And the wind tunnel, that it requires a close interaction with the wind tunnel agency, which is Professor Wacker in this case from nearby Stuttgart, who is a dedicated expert in this field, so that he understands from the model-based readings the fluctuation of the measurements at the pressure taps, which are embedded within the structure in the physical model in the wind tunnel test. He can calculate the dynamic implication on the structural model, which results in dynamic amplification factors for us, and those we have to consider in our structural modeling again. And now with this dynamic amplification, which is also localized topographically in the model because it's a full 3D analysis, we can actually, of course, align those spots where we have actually space to equip our damping systems with those where these maximum excitations occur. And then with this revised response of the system, by having this mass damper, which is calculated by us in terms of frequencies and eigenvalues, the physical testing is redone again. And that is a procedure which is relatively new, because at least in such large span applications, it hasn't happened yet. But on the other hand, it's only a, let's say, digitalized procedure to what you've seen from this footbridge, where our team was jumping up and down to accelerate the bridge and to measure the response and to decide if measures are required or not. So in principle, they are very much related.
Okay, thank you. I think that before people get too tired, we must come to an end. Like all things must come to an end, howsoever joyful they may be. Can I request Professor Visalakshi, if she's there, to propose a vote of thanks?
Dr. Visalakshi is not there. I think she's so.
Alok, would you do the honors of proposing a vote of thanks for this fantastic?
Yeah, it will be my privilege. It's a great privilege for me to propose a vote of thanks. I think today what we saw and what we heard is a treat, is a real treat actually. And I profusely thank Mr. Knut Stockhausen and Professor Mike Schleich for this excellent presentation. It is really inspiring for not only the young engineers, those who have participated to listen, but also to, old fossils like us. I mean, this is extraordinary, and it gives us an additional energy. Tomorrow when we start the day, it will be with a little additional energy with this kind of presentation, because it opens up so many ideas which, which come. And I also take this opportunity to thank all the participants. We have been regularly conducting such kind of technical webinars and presentations, and we have been getting large participation, which gives me a feeling that, all I'm sorry, I think there is a problem of signal. So, am I audible now?
Yes.
Okay.
And incidentally, one of the comments which has just come up is that you are not an old fossil as you claimed in your last remark. Please continue.
Okay. So I will conclude by once again thanking all the panelists and all the participants, and I would look forward to some more similar kind of presentations in the times to come from both Professor Dr. Mike Schleich as well as Mr. Knut Stockhuisen. In future, I think, like in industry academia interaction, I would like to have more industry interaction between Germany and India. So with these words, I would like to end this session. Thank you once again very much, and thanks profusely for accepting our invitation and making this presentation, Mr. Knut.
Okay, thank you very much. I think we have exhausted ourselves, if not the time. So we will let the everybody go back to whatever they were doing or not doing.
Yeah.
And have dinner and go to sleep.
If we see the chat box,
sorry.
If you see the chat box, it is full of praises and congratulations and thanks from all the participants.
Yes, I think that there is a very large number of people who have praised the presentation, and they have brought out what they have learned in during the last couple of hours that we have been participating. And many people have said that it was an honor, and you got many followers, Mr. Knut. They say that you are the ideal, and it is a thrilling experience, and you can, any number of adjectives you can think of are there. So
I really appreciate that.
So if you want to feel good, please have a look at the chat box also, and also the question and answer session, because we have taken only a few questions due to the paucity of time.
I saw there are some other questions. If you, I can't answer all these questions now, but feel free to contact me through LinkedIn or so, and write direct questions, and I will respond to every single.
Okay. Okay, so that's an
invitation.
Thank you. Thank you very much.
Thank you very much.
So I think.
Thank you, sir. Thank you.
Thank you.
I think with that we can end the current session. Thank you very much, one and all.